optics number 5, optical instrument. Let's move to the optical instrument. Write a subtopic, visual angles. Visual angle. I will tell you what is the visual angle, right? Okay, look at here. Let's say this is your eye. This is your eye, right? This is your eye. Here, if you place an object and the object form an image on the retina, the object form the image on the retina. Actually, this is the image. If you take that as an object, this must be the image. Always need to draw the arrowhead for the ray diagrams. Huh? Okay. Always draw the arrowheads. Right. Let's say this is alpha. This angle is alpha. If that is alpha, this must be alpha. This must be alpha. So alpha is called the visual angle. Then what is the visual angle? Visual angle is the angle projected by the object onto your eye lens. The angle projected by the object on your eye lens. That is what we call the visual angle. Let's say the size of this HI. This is H0. Right? We get an inverted image, as I told you, inverted image on the retina. So the signals go through the optical nerves to our brain. The brain identifies this as not inverted one, is a erect one. That is how the things are happening. Let's say the size of this eyeball, diameter of this eyeball as A. The size of that is A. Okay. The size of that is A. Okay, write a subtopic, visual angle. It is the angle subtended. It is the angle subtended. It is the angle subtended on the eye lens. On the eye lens. On the eye lens. By the object. By the object. By the object. Right. Shall we draw this one? Done. Right. Okay. Look at here. If you take alpha, that is called the visual angle. Alpha is called the visual angle. Alpha is called the visual angle. Tan alpha is equal HI over simple A. HI over simple A. Try to understand this alpha are very small angles. This alpha is very small angle. Alpha is very small. If alpha is very small, if you remember the approximation, tan alpha, you can make it as alpha. Even that is true for the sin alpha. Sin alpha equal alpha, given that alpha is very small. If so, tan alpha, either of tan alpha, somebody can take it as alpha. Alpha must be equal HI over A. So that means HI must be equal to A into alpha. The size of the image which is placed on the retina is determined by the visual angle. That means the size that you receive on the retina, the size of the image that plays on the retina is depends on the visual angle. Higher the visual angle, the image size would be very high. So to observe the things properly, to observe the things properly, you should have a clear or the large or the considerable visual angles. Otherwise, you can't see the objects properly. Am I clear? For a human eye, if there is no defect, can one of you tell me what kind of a value it should be? I mean, if the visual angle is this much of value, if the visual angle is less than this particular value, you can't see the object properly. Can one of you suggest me a value for that? Any one of you? What could be the visual angle for that? It is not 1 degree. It is not 1 degree. Anyone else? Any guesses? No, it's not 20. No, it is not that. It's called 1 minute. It is 1 minute. Okay. If the visual angle is less than 1 minute, we can't see the things. Okay. There are exceptional cases. You know that now. There are exceptional cases even for 0.0005 minute, the things can be seen there. There are exceptional cases. I'm referring to the normal typical situations. Okay. Right. Put a stand right. The image formed by the eye lens, the image formed by the eye lens, the image formed by the eye lens. Have to complete this diagram? Okay, the image formed by the eye lens is inverted, comma, real, comma, diminished. Diminish. And the image distance is constant. Image distance is constant. Image distance is constant. Right. Within bracket, right? Alpha is considered as the visual angle. Alpha here is considered as the visual angle. Alpha here is considered as the visual angle. Now we'll write tan alpha equal hi over a. Alpha is very small. Tan alpha is very small. Sorry, alpha is very small. If so, therefore, tan alpha is approximately equal to alpha. Alpha is equal to hi over a. Hi equal a into alpha. Since simple a is a constant, somebody can tell that the size of the image is proportional to the alpha visual angle. Visual angle. Put a stand right. Therefore, the apparent size, a bit of pain size, the apparent size, therefore, the apparent size of the image of the image which is on the retina, which is on the retina is directly proportional directly proportional to the visual angle. To the visual angle. Right, now I'll be taking you to a different position, different locations under the same section. Look at here. This is the eye lens. You may have objects at this location and think about the visual angle projected. This is the visual angle. The size of this image is I1. The size of the image is I1. Let us take the object as O1. Now, what I'm trying to do, I take the same object to a different position. This is alpha 1, okay? This angle is alpha 1. This is alpha 1. Now, I'll be taking you to a different position. The same object, let's say this is O2, the same object. Now, the projected angle on the eye is alpha 2. It is very clear alpha 1 is greater than alpha 2. Alpha 1 is greater than alpha 2. Identical object. But the thing is, the image now I2 is less than I1, or simply I1 is more than I2. Same object. When it comes to two different positions, you get different size of images. Different sizes of images. You feel that this object is not the same size, different size, very far away from your eye. Same object now, but different visual angles develop different sizes on your eye. Okay, right. Let's move on to that part. Okay, just okay, we'll write like this. The object O1, object O1, object O1 appears larger than the object O2, larger than the object O2, larger than the object O2, although their physical sizes are the same. 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 The other word I can make like this. Let's say you have a certain large object. Now it is close to your eye. The same object, you can see this object very clearly, no problem. But the same object now take to a very large distance, considerable distance from your eye. Now, the same object project on your eye with a very small visual angle, maybe you can't able to see it. Can you understand that? That is true. Even though the object size is physically considerably high, you can't see the things properly because the visual angle projected on your eye very small. Right? If you can't take the sun or the moon to your close to your eye, no. But when you look at very far distance object, maybe those objects are not visible for you. The reason is the projected angle on your eye is probably small. Okay. Maybe when it comes to when you take your close to your eye, it's difficult. It's easily you can see the things. But when you go beyond a certain distance, it's not possible to see the things. Further the point, visual angle is small. Okay. Right. Shall we draw this one? Now I'll be referring to this kind of instance. What is that? This is the size of the object image. Sorry, the size of the image. Now look at here. The object can be placed at this point. Let's say it is O1. Now the different size of the object now placed at O2. These are objects. What is the conclusion? Even though the object size O1 and O2 are totally different, the physical appearance on your eye is the same, isn't it? They are having the same values on your eye. We feel that O1 and O2 are having the same magnitude, same size, regardless of their actual situations. This is very large compared with that, but you feel that both are the same. Both are the same. That's another issue. That's another instance that you need to know. Next point. Object O1 and O2. Object O1 and O2 appear the same size. Appears the same size. Although appears the same size. Although appears the same size. Although object O2 the size of the object O2 is larger than object O1. Size of object O2 is larger than object O1. I will take you another instance. Right? Now, this particular object is very close to your eye. This object is very close to your eye. Very close. Think about the visual angle projection. The visual angle projection alpha 1, let's say alpha is very small. This is the image I. Alpha is very small. Alpha is very small. When the object size is very small, even though that object is very close to your eye, the physical appearance on it is small. Am I correct? Clear? Okay, then right. Okay, next point. Object appearance is very small. Object appearance is very small, although that object is very close to islands. Within bracket, right? Object physical size is very small. 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 Okay, right. Right. So what actually the optical instrument is doing now? The optical instruments main function is to increase the visual angle so you can see the clear objects. You can develop a clear image on your eye. Therefore, you can see the clear objects. The main function of optical instrument is to improve the visual angles, to increase the visual angles, increase or improve the visual angles. There are mainly two types. One is the microscope, other one is the telescope. So today we will start to discuss the microscope and telescope. Okay. The main requirement is to increase the visual angle so that image is very clear and it provides the clear understanding about the image. Okay. Put a stand right. Optical instruments are widely used. Optical instruments are widely used. Optical instruments are widely used to increase the visual angles. To increase the visual angles of objects of objects of objects which can't which can't which can't see clearly, which can't be seen clearly, which can't be seen clearly by the naked eye. Naked eye means without any using any spectacles or any other devices. Naked eye, within bracket unaided eye. So we all again call it unaided eye. Unaided, UNAIDED, unaided eye. Basically, there are two types of optical instruments. There are basically two types of optical instruments. Number one, microscope. Number two, telescope. Number one, microscope. Number two, telescope. Right. Without going into detail, I will go with the detail. Microscope is used to improve the visual angles of very small objects. You have the issue now. You know now, if the object is, even though the object is very close to your eye, if it is very, very small, the visual angle projection is very small, so difficult to see that. To improve it, to increase the visual angle, we use a device called the microscope. So the purpose of telescope is to see the distance object. The object might be very large, but the projection angle, the visual angle is very small there. So to improve the visual angle of those objects, even though they are very big, they are far away from you. So we need a telescope. That's the main function of those two devices. So we'll start the microscope now. Write it a bit, microscope. Right under that. Microscopes are used to obtain large images within bracket, improve the visual angles or increase the visual angles of close objects of close objects of close objects of close objects. of those objects. Right. So before come to the microscope, if I give a overview of that, there are two types of microscope. One is called the simple microscope. The other one is called compound microscope. We will discuss what is simple microscope and compound microscope separately. But for that, for those two types of microscope, there are few definitions that you need to know. What are the definitions? Called the angular magnification. We are discussing something called the magnification, angular magnification. You know that there's something called, we call the magnification under the optics, magnification, image height divided by object height, image distance divided by object distance. Here the magnification is called the angular magnification. It's related with the angles. Angular magnification. Angular magnification, I will define that. It is capital M. It is beta over alpha. I will define what is beta and what is alpha. Beta. What is beta? Let's say this is your eye, and when you place your object in front of it, and you may place a kind of microscope. Because of the microscope, the image form somewhere here, maybe somewhere here. If the image forms here, it provides a kind of angle on your eye lens, that is the beta. So beta means what? The angle projected, angle projected on your eye by the final image. This is the final image. Final image by the microscope. Angle projected by the final image of the microscope on the eye lens, that is called beta. Then what is alpha? That alpha means you place your eye lens, you place your object at a d distance. What is d here? It is 25 centimeter. Least distance of distinction. It's a d distance 25 centimeter. Think about the angle projection, that is alpha. It is the visual angle alpha. Alpha is this, beta is this. Can you understand the idea? Do you have the idea now? That is what we call the beta and alpha. Always remember, whatever the refraction or those things, finally they are the image of that image form on the eye lens. It is beta. Right? It is beta. Actual scenario is, I will come to that later. Okay, I'll come to that later. But anyway, you can understand beta and alpha. Right topic, angular magnification. It is defined as capital M equal beta of alpha, where beta equal angle sub 10 on the eye by the final image of the microscope, by the final image of the microscope. By the microscope. Beta. Angle subtended on the unaided eye. By the object when it is at near point. So normally 25 centimeter within bracket 25 centimeter, comma, capital D. We normally take it as capital D here. Capital D. Right. If you want, you can just draw that. I'm just highlighting that part. No need to draw that. If you want, you can draw that. No problem. For the same point, I wanted to discuss this one also. Since alpha and beta are very small angles, somebody can take, since this is the definition. This is the definition. Since alpha and beta are very small angles, somebody can take as tan alpha equal to alpha, tan beta approximately equal to beta. So the equation now modified as tan beta over tan alpha. So you can take that value also when it comes to questions. Okay, right? Write a topic, adjustment of the microscope. Adjustment of the microscope. What is meant by adjustment? Look at here. I will move to the adjustment of the microscope now. Right. Pay your attention to the adjustment. So my adjustment means what? I will explain. If you take your microscope, this is your eye lens. If you take your microscope, you can probably keep the microscope in front of this lens. Let's say this is your microscope. This is your microscope. So when you place a microscope in front of the lens, the image would form at different positions. Now image can form in different position. At this point, maybe here, maybe there, with different sizes. But that means infinite number of locations are there. But you need to know that we mainly focus on two locations. We mainly focus on two locations where your final image is taken. One is at 25 distance from the eye lens. From the eye lens, it is 25 centimeter from the eye lens. Since microscope also very close to the eye lens, you can take from microscope. We make the image at 25 distance. That's the one thing. That is called normal adjustment. If you are doing like that, it's called the normal adjustment. There is something called the abnormal adjustment. In the abnormal adjustment, we take the final image to infinity. So even though there are millions of locations to take your final image, we mainly focus on two locations. One is near point, which is at 25 centimeter. If you do like that, we call it normal adjustment. The other adjustment is abnormal adjustment. We call it is called abnormal adjustment. We make the final image to infinity. Clear? Understood? You all are clear with this? Yes or no? Are you okay with this? Every one of you? Clear, right? Every one of you? Kavisha, how about Kavisha? Are you okay with this? Clear, eh? So if you have anything, you can ask me. Don't wait till I ask your questions. If you have anything, you can ask me. Remember, there are two adjustments. What we interested is these two adjustments: normal adjustment and abnormal adjustment. This concept that we discuss here is common for both simple microscope and compound microscope, which will be discussed soon. Write a subtopic: adjustment of the microscope. Adjustment of the microscope. Let's move to adjustment of the microscope. Adjustment of the microscope. Adjustment of the microscope. Right under that, microscope can be adjusted. Microscope can be adjusted to form the final image. To form the final image. To form the final image. To form the final image from near point to infinity. From near point to infinity. So we have infinite number of locations, infinite number of locations for the final image. Infinite number of locations for the final image. However, we mainly focus on two adjustments. Number one, normal adjustment. Normal adjustment. Right under that, final image formed by the microscope. Final image formed by the microscope. Final image formed by the microscope is at the near point. Final image formed by the microscope is at the near point. Abnormal adjustment. Final image. Abnormal adjustment under that. Final image number 2. Okay. Abnormal adjustment number 2. Final image formed by the microscope is at infinity. Leave a line and write. There are two types of adjustment. There are two types of microscopes. Number one, simple microscope. Number two, compound microscope. Number one, simple microscope. Number two, compound microscope. Write the topic: simple microscope. Simple microscope. Right. My simple microscope is simply a convex lens. Nothing else. It is simply a convex lens. Okay. Right under that. Simple microscope is a convex lens. Is a convex lens. Is a convex lens. Okay. So if I give an overview, what I'm going to do under this particular part, I'm trying to draw the ray diagram for the normal adjustment, and I'll be developing an equation for the angular magnification. Same thing I'll be doing for the abnormal adjustment as well, right? After that, my simple microscope is completed. Then I will start with the compound microscope and draw the ray diagram for the normal adjustment. For the normal adjustment, draw the ray diagram for the normal adjustment and derive an equation for that angular magnification. Then draw the ray diagram for the abnormal adjustment, okay, and derive an equation for the angular magnification when it is abnormal adjustment. In syllabus, they only refers to the abnormal adjustment. When it comes to the abnormal adjustment, they only refers to the ray diagram. No need to derive the equation for the abnormal adjustment. But I think there's a small section better to discuss that, better to complete that part also, because the knowledge that you get from there is important when it comes to question. So let us derive all those four equations for the simple microscope and compound microscope, right? Write a subtopic when the simple microscope is at the normal adjustment. When the simple microscope is in normal adjustment. When the simple microscope is in normal adjustment. When the simple microscope is in normal adjustment. Look at here, one of you. Here, this is your lens, convex lens, as I told you. Right? This is the convex lens. Okay. What is our requirement? The close object, the object which is very close to your eye is placed close to the convex lens, is a simple microscope. Let's say your object is, this is your object. Since this is a normal adjustment, you need to place your final image where? You need to place your final image at where? You need to place your final image at the near point. Right? Look at here, I'm going to do this. Here is a convex lens. To form the this is the focal length of that lens is f. Let's say it is f. To form the image on the same side is a virtual one. We need to place your object in between the focal point and the optical center. Focal point and the optical center, then only the image would form on the same side. Here, when you draw the ray diagram, a ray which is go through the ray parallel to the principal axis. After the refraction, go through the focal point. That's the one ray. We can draw another ray which is go through the optical center. It will go through the optical center. Okay. It is very clear. In this side, you can't develop an image. Your eye is placed close to this location. I will draw the eye also. Actually, the eye is close to this microscope, simple microscope, right? Simple microscope. Now let's extend this line. When you extend this line, you can see the image formed at this location. My point is this particular distance must be equal to capital D if it is the normal adjustment. If it is the normal adjustment, it is equal to capital D. So in this particular case, we assume that our eye and the microscope does not have any separation, any distance in between those two. But you know the real situation is not that there's a small distance now, but we assume that there's no distance between the two lenses, the microscope and our eye. Understood? So this is the final image location, least distance of distinction. Here in the exam also they will ask you to derive equation for the angular magnification. I'm trying to derive it. Here we take this angle as beta. This is the beta. We take that as beta. So someday you might feel that the final image is this. This is the final image I. Let's say it is HI and that must be HO. Final image projected our eye, the angle projection is beta. We have taken that. Sometimes you might feel it is not on the eye but on the lens. Since there is no distance between the eye and the lens, we take that as, we assume that eye is contact with the lens, so it is same as beta. That is a kind of assumption we take. That's no problem with that assumption. Okay. And if you take the eye lens like that, your object is B alpha. Alpha is called what? This is the alpha. When you place your object at a d distance, that's called V alpha, H naught. Now we'll derive the equation for the angular magnification. Angular magnification equal beta over alpha. So beta I define, I have highlighted here, alpha also I have highlighted. When they ask you to do that, do like this. It's a definite requirement. Definite requirement. Here when it comes to this point, you can say alpha and beta are very small angles. Alpha and beta are very small angles. Definitely these things must be there, otherwise you don't get the full marks. Therefore, tan alpha equal to alpha, tan beta equal to beta. What is tan alpha then? Tan alpha, H naught over D. What is tan beta? Tan beta equal Hi over D. Hi over D. Now, capital M equal Hi over D, H naught over D. Hi over H naught, because D come to this location. If you want, we can simplify Hi over D, D over H naught. Cancel no Hi over H naught. It is Hi, image height divided by the object height. Image height divided by the object height is something like that. Image distance divided by the object distance. Let's say the object distance as U. I will take that as U. I will take this one as U. Okay, I need to derive further. Can you complete this part first? They allocated marks for these definitions, these points, so don't forget. Arrowheads must be there, beta mark, alpha mark here. Like that, you need to do those things. Right, done. Right, okay. Now this is HI over H naught. Okay, I will erase the board. Magnification, we have reached up to this point, HI over H naught. HI over H naught. Here, HI over H naught, image height divided by the object height. If you remember, it is same as the image distance divided by the object distance now. Okay. Image distance here is D. Object distance is U. So it is our duty to develop a relationship for the D over U. D is clear, no problem, because D is 25 centimeters, okay. But this U must be like depend on the situation, depend on the situation. So let us use the lens formula for this lens. Lens formula, lens equation. Lens equation for the microscope. For the microscope. 1 over V, 1 over U, 1 over F. 1 over V is D. It is positive because we know that based on the sign convention, this is positive. These distance are positives. Minus 1 over U, minus 1 over F, it's a convex lens. Multiply all the terms by D because we need to derive for the D over U value. 1 minus D over U minus D over F. Take it to this side, take it to that side. 1 plus D over F equal D over U. So it is very clear D is a known value. Even the if focal length is a given value. Normally the microscope focal length will provide it. For simple micro, they will tell you. So with that, we can find the magnification value. Capital M now equal to 1 plus D over F. Remember this, okay? You need to remember, don't forget. You need to remember. For the MCQs, you need to remember this way. D over F. F is 1 upon F now, inverse of F. So that means if you go with the power, it is 1 plus dP. 1 plus dP. Okay, both need to remember. 1 over F means power. Okay, can you come to this point? For the simple microscope, please remember 1 plus D over F. Under the normal adjustment, this is the equation. 1 plus dP. Right. If you have done, write a question. Plot a graph to represent angular magnification versus the power of the microscope, power of the simple microscope, angular magnification versus the power of the microscope. Try yourself. This is the angular magnification. This is the power of the lens. Angular magnification equal 1 plus dP. Think about that. No, actually, it's not vehicle MX. No, it's different. It's not vehicle MX. Yes, it's y equal mx plus c type graph. Look at here. They ask you to plot looks like y. I will make a small modification, capital M, 1 plus PD. No, no problem with that. Let's take y. It is dp plus 1. D means like looks like gradient. This is looks like x plus c type graph. This is the graph you would get. Right? Instead of the power, if somebody take the inverse of the focal length, that also the same type, 1 over f, okay? The same thing, okay? Alright? Within bracket, you can write that one also. So we did simple microscope normal adjustment. We did simple microscope normal adjustment. Now we are going to do simple microscope abnormal adjustment. Right? We will do that now. Write a topic. Write a topic. Please write a topic. Abnormal adjustment of simple microscope. Abnormal adjustment of simple microscope. Abnormal adjustment of simple microscope. If that is an abnormal adjustment, where would be the final image? Where is the final image location? Where is the final location of the image? It is at where? It is at the infinity, ne? It is at the infinity. Look at here. Okay. This is the focal point of the lens. Simple microscope is simply a convex lens. That is why you draw it. The object is now placed in front of the lens. The image need to be go to infinity. To develop that, where is your location of the object? To develop the final image on the infinity. On F, yes, we can't draw like that. We need to arrange the object on top of the focal point. Then that is go through the focal point. It is go through the optical center and extended this line goes to infinity. So if you look at through this, you could see the image is at the infinity. Image is at the infinity. This is beta. As I told you, this is beta. The angle subtended by the final image on the eye. It is beta. This is the focal length of the lens f. And apart from that, we have to consider this is at the d distance h naught. This is h naught. This angle is alpha. This angle is alpha. Now we will go with the definition. Capital M equal beta over alpha. Don't forget, alpha and beta are very small angles. Right? Capital M equal tan beta over tan alpha. Tan beta over tan alpha. Then what is tan beta? Tan beta, it is equal to h naught over f. H naught over f. What is tan alpha? It is h naught over d. Now capital M equal tan beta h naught over f tan alpha h naught over d. H naught cancel. Capital M equal d over f. D over f. Capital M equal D over F. It's a one relationship. Instead of F, somebody can write capital P. M equal BP. BP. So out of the two magnification, where we get the maximum angular magnification? Either the normal adjustment or the abnormal adjustment. It is the normal adjustment 1 plus dp, but here it is dp. Understood? So in a question, they could ask you, simple microscope is now at the maximum angular magnification. What is your answer? Do you need to get any other idea? Because we know that it's magnification, maximum magnification is maximum angular magnification, and where it is when it is at the normal adjustment. So that tells us this is now in the normal adjustment. So remember, okay, right? Let's move to this part. Image is at infinity. Image is at infinity. Okay, done, right? Right. Okay. Pay your attention to this. When it is on the normal adjustment, the magnification equal 1 plus d over f. Under the abnormal adjustment, it is normal adjustment, normal. Abnormal adjustment, it is simply d over f. It is abnormal adjustment. So what we expect by using this kind of lens to improve the angular magnification, to increase the angular magnification. We all like if you have very high angular magnification because it tells us a good picture on our eye. We like it. But to improve the angular magnification, we need to reduce the focal length. We need to reduce the focal length. When you reduce the focal length, what happens? What happens? When you reduce the focal length, what happens? The thickness of the lens, what happened to the thickness of the lens? That increases. Because to reduce the focal length, we have to reduce the radius of curvature or to increase the curvature. Then what happened? The thickness of the lens would increase. Focal length reduce. Focal length reduce. So that develop an upper limit for the simple microscope. If you are using simple microscope, that develop an upper limit. You can't go beyond that. What happens when the thickness is very large? When the thickness is very large, the picture is not clear. The blurred one. Okay, the picture is not clear then. When you have a very high thickness, the thickness which have a high thickness one, the picture is not clear. So simple microscope has now a limitation. We know that we need to use a very small focal length to develop the angular magnification. But when you are using higher angular magnification, the thickness of the lens need to be high, then the image, the final image is distorted. What we expected is not done now. Neither is issue. So that develop an upper limit, that is why the compound microscope is developed. The compound microscope has two convex lenses where it develop higher magnification clearly without than this. Clearly, right? You need to understand this one like a story. I'm trying to teach you like a story, so you better get it from like a story. Then you have things in your mind. I'm not doing anything arbitrary, right? I'm not doing anything arbitrary. I'm doing like a story, how it happens. I explain everything clearly, so it is easy for you to get the subject without any problem. Okay, let's move to the section. Put a stand right. It follows that it follows from the both expression. It follows from both expression. It follows from the both expression. Follows from the both expression that the length of short focal length, that the length of short focal length, that the length of short focal length is required to obtain higher magnification power or higher magnifying power, to obtain higher magnifying power. Obtain higher magnifying power. Leave a line and write. The surface of such a lens, has to be highly curved. Surface of such a lens has to be highly curved, in order to decrease the focal length. Highly curved in order to decrease the focal length. Right, shall we draw that? Focal length reduce. Thickness of the lens increases. So this is our plan. Okay, after that I will tell you thickness of the lens. Thickness of the lens increases. Okay, just write under that. The final image is distorted. The final image is distorted with highly curved lens. With highly curved lens. The final image is distorted with highly curved lens. Thus, this set up an upper limit. Thus, this set up an upper limit. Thus, this set up an upper limit to the angular magnification. To the angular magnification. To the angular magnification that can be achieved. That can be achieved. That can be achieved. That can be achieved using a single lens. Using a single lens. This problem is resolved. This problem is resolved. This problem is resolved. This problem is resolved. This problem is resolved using compound microscope. Compound microscope. Compound microscope. Right. Okay. The next part is the compound microscope. So I took more than like 20 minutes from the normal time. Now the 12:20. Right. For the compound microscope, we will shift that on to the Tuesday class. So, Lamai, this is our plan. This is our plan. I'll be completing the optics section in coming Tuesday class. So you know that under the thermal physics, as I listed, there are several sections we have. What are the things that we need? The thermometry section, thermometry, that is the first topic. Expansion of solid, that is the second topic. Expansion of gases, that is the third topic. Sorry, expand the thermometry section, we did it. Thermometry, expansion of solid and liquids. Third one, expansion of gases. The fourth one, calorimetry. Fifth one, heat transfer mechanisms. I think by now you got the tutorial for that. I mean, the 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 the, the, the notes to receive now. So this is our plan. After completing the optics section, next Tuesday, coming Tuesday, I'll be completing that part. After that, I'll continue the point where I have stopped. Under the thermal physics. Now I have completed the third topic. Uh, Thermometry part I completed. Expansion of solid I completed. Expansion of solid and liquid I completed. Expansion of gases also complete. I think I need to discuss few questions on that. I will discuss that. Don't worry. From their point onwards, I'll be continue the thermal physics once I complete the optics section. Let me to complete this optics section fully. So that is normally Tuesday class will continue the thermal physics section. Right. From next Saturday onward, we'll start the reverse class. There are several students request regarding the reverse class. Please let them to know also. So we all are not taking any additional payment from the students who all are joining the theory class. We all are not taking any additional payment. Theory class, the paper class, theory class, and the reverse class. You have 3 classes per week. All these things are to complete your content properly. I'm not just covering the topics. I mean, I do my best for you to get the things right. So what you need to do is engage with these 3 classes as a live class. Don't keep those things to watch at a later stage. You can't do it. You can't do it because the same way that other teachers are also doing the things now. Your chemistry teacher, biology teacher, always join the live classes and complete that done then. No problem, no need to look at that again. I mean, if you have any issue query, you can go with the recording and watch them because I uploading the recording with a small delay now. I will uploading the recording with a small delay. Okay. So try your best to understand. Always engage with these 3 classes. Tuesday, the theory class continue. The reverse class continue on Saturdays. Actually, I started with 7:30 to 12:30. The reverse class is prepared and scheduled. And maybe the reverse class go beyond 12:30. The reason is, you know, that I'll be completing the section like elasticity section is the next coming week. I will complete elasticity, surface tension, viscosity. So all these 3 sections I need 3 weeks. Right? You know, it's not an easy task. Huh? It's not an easy task for you and for me, both. Right? For you and for me, it's both. It's difficult. But if you do that, the lesson is completed. No, you need to believe in me. I'm not doing anything. I'm not skipping anything. I'll cover up all the sections. We cover up that section, completing a single lesson within the 3 weeks is very, very important point. Right? You need to believe that. I think the most of the students were in my class from the very beginning. They also watched the recording. Most of them are not doing the live class, unfortunately. But the students who are in my class, they are regular in my class. They have a belief in me. I'm doing the best. So nothing to worry. If I do that certain lesson, that means I'm doing it the maximum. So nothing to worry. So let you need to help for me to do this one also. When I ask you to do homework, please do the homework and join the next class. Otherwise, not meaningful. So it is not an easy task anyway to complete these 3 lessons in the 3 weeks. Sometime I will be increase the time duration also, but anyway, I'll complete these 3 lessons. So 3 complete lesson means you get the chance, you get the opportunity to complete one essay question at the exam. I mean, definitely you will get an essay question from mechanical properties of matter, and also 4 5 MCQs every year. So you get that chance in advance. In advance, please educate your friends also who like to join the reverse class. It's a benefit for them. You know that we don't know exactly when will be our term exam. I mean, not the term test, 2025 level exam. So we need to prepare in advance. Don't know, they will give, they will tell you it will be on August. We don't know. Sorry. We don't know exactly they will place that in August. We don't know. So what we need to do is we need to prepare in advance. So that's the main purpose of doing this reverse class. And the other side, I'm not trying to discuss these things with you. I'm not get any additional benefit of doing these kind of classes. I'm not taking any extra money from you all. No, I'm not taking any extra money from the students who are joining the theory class. But if you think in the, I'm not criticizing anybody. Do you think that the most of the teachers would not do these things? I'm telling you, some students they don't have the value on this. That's why I'm telling you. I'm not normal telling these sections, these things. It's pointless. But some students don't have a value on that. That is why when we give free of charge certain things, they don't have value on that. That is why I'm telling you. So do you think that the most of the years they do like this? They are not doing like this. They take every class. They take the money. I'm not doing that. Right? There are several students who are in my class, which we provide the free cards, free cards. Okay, so that is how we do the things. Finally, what we expect is a good results. So remember, I'm always telling you that is the best opportunity you have. Do the maximum at your A level and get a good results and get a good position in the society. This is the best place you can do that change, right? If you just skip that, you don't get the chance. I'm not telling you that the people who are not that much educated are not having the position in the society. They also have, but if you learn the things, if you are go to university, if you go to university and score there, the life is not that much difficult, right? They would do the same thing, but they have to do lot of things to develop up to your standard. If you learn the things properly, if you get the opportunity, don't skip. That's what I'm telling you. So this is our plan. This is what I want to emphasize. I'm always telling you these things. The students, you all are forgetting the certain part. uh, that means March 20 22nd I'll be starting the reverse class. 22nd, the last essay section completed. March 1st, I'll complete the I'll complete the March 1st means I'll complete the Viscosity, March 8th, I'll complete the surface tension. That is how it goes. On 15th March, I'll start the new lesson. Probably the last lesson, matter and radiation. Matter and radiation. I'll start the matter and radiation with you on the March 15th. So this is how the things are planning. I try my best to complete the syllabus in advance. So please help us. When we ask you to do questions, please do and join the class. Then there is no problem. And let the other students also know about the reverse class. The last time lot of students joined the class, the reverse class, they also got the benefits. Please inform if there are any students who are willing to complete their syllabus in advance. This is the best opportunity they have. And regarding the paper class, please prepare and join the paper class. Some students are scoring very good now. They are scoring properly. So you need to score every paper. I'm preparing the paper in a certain level. You can't simply score for the paper like what I'm preparing. You need to work hard to prepare for that. And otherwise you don't get the marks. Prepare and join the class. From next week onwards, if I'm going to give a essay paper, I'm going to tell you which section I'll be questioning. For example, under the thermal physics, I'll be questioning under the just example. Okay, for the mechanics, I'll be questioning you like from the fluid dynamics. So you need to look at the fluid dynamics thoroughly and join the class. So don't skip that. If you will follow the what I'm telling here, you will feel that the improvement is rapid. Right? So we will discuss the way that we discuss here. We will do the things that we discuss here. Feel free to question us anytime. If you have anything, you can send me the message. I will reply on this. Anyway, get a good results. That's the final target, you and me both. Okay. So we'll meet again on the Tuesday class. During Tuesday class with the optics section, I'll be cover up the whole section on that day with the telescope. Okay. We'll meet again on Tuesday.